Hi, welcome to my Weka project on LAB06. So in this lab, we will be investigating laptop press CSV file. So I will already open it up in Weka as let's take a quick browse around the dataset. So there are 7 attributes in total, and as we can see, there are brand, processor speed, RAM sets, storage capacity, screen sets, weight of the laptop, and also the price of the laptop. So our ultimate goal will be using these 6 attributes to predict the laptop price as precise as possible. And we have already replaced the missing values and also remove the duplicated values. And let's take a look. There are 1,000 instances in total, and just for convenience, let's visualize all attributes. As we can see, the attributes are distributed pretty evenly. Like there are around 200 instances per brand, and the other factors are distributed pretty evenly, and the price are distributed throughout certain intervals. And let's go to the classify. And so in this dataset, we will be solving a regression question rather than a classification question. So we can choose many of the classifier like the naive Bayes and also the logic SGD. And we will be implementing tenfold cross validation here because the sample size is reasonable, and there's no like extreme outliers and no missing values, so perfect for cross validation. And let's begin. So price is our target variable, and we are using cross validation here, tenfold cross validation, and we just chose the simplest classifier 0R. Let's see what we can get. So for regression questions, there's no precision. Rather than that, we have a summary here. The correlation coefficient is negative 0.0727, which is very bad. It's not even positive. And the error, mean absolute error, root mean squared error, and also the absolute error and squared error, they are all extremely high. So we can deduct that 0R is a bad classifier in this question. So let's take a look at the linear regression classifier. And it gets a relatively good result with a linear regression model listed below. And it uses a formula to try to predict the price. And the correlation coefficient is 0.9998, which is pretty good. And the errors are relatively small. Let's take a look at another one. So this time, let's take a look at the random forest. It's relatively slower because random forest is large, and the correlation coefficient is also pretty good, I'd say, and the errors are relatively small, even though it's a little bit larger than linear regression. And let's take a look at the random tree, sorry. This time the error is even larger, and then I've also found some interesting classifier. So I also found a quite interesting classifier called additive regression. So the idea here is instead of building one big model at once, additive regression builds a model step by step, like this. And each step it adds a new model that tries to fix the mistakes made by previous ones. And as you can see, there are model number 3 all the way down to like model number 9, and also the result is pretty good. It's pretty impressive, and there are also like good models in Weka that I've tried, but due to the time I can't show you all of them. And at last, I just want to show you guys. In the visualize panel, we can see how each attribute can correlate with the other ones. Like you can see the correlation between rate and price and other stuff.